All right, this video will help you with combined gas laws and the quiz that you are taking. I'm going to have 5 practice questions, okay? So first practice question, there's a rigid steel container with a constant volume of oxygen gas. The initial pressure is 490 kPa and a temperature of 22 degrees Celsius. The temperature of the gas decreases to negative 24 degrees Celsius. What will the new pressure be? All right, so first thing, you look at this question, and anything there's a number, we're going to put it into our table. So initial means we start with, so those are our ones. So I have a pressure of 490 kPa, so I'll put that right here, 490. And I like to put my units in my table. And the temperature is 22 degrees Celsius. And right now we're just going to put it in the table. And then it decreases to negative 24 degrees Celsius. So that's a new temperature. So I just put that in my table, and that's why it's a number 2. And then it says, what will be the new pressure? So we do not have that. That's going to be our unknown in X. It doesn't say anything about volume. Besides that, it's constant. Constant means it's not going to be a factor. So we can cross it off in our table, and we can cross it off in our equation. So the V2 and V1 are gone. So now that my table's set up, it kind of helps me set up my problem. The last thing I need to do is convert my temperature, Celsius, into Kelvin. And notice my table, it shows you, all you have to do is add 273. So 22 plus 273 is 295. And now it's in Kelvin. And then negative 24 plus 273 is going to be 249. Now we're just going to plug this into our equation. So P1 is now going to be 490 over T1, which we said now is 295, equals to P2, we do not know. You can leave it as P2, or I'm just going to use X for this video. And then T2 is 249. And as always, if I'm ever going too fast for you, pause my voice. It's a great feature of having videos. Yay! All right, so now I need to solve for X. What I like to do if I see 2 fractions on each side is cross multiplication. So when you do cross multiplication, some people like to call this the butterfly method, because watch this, it's going to look like a beautiful butterfly. So 295 times X will give you 295X equals to 490 times 249. And for right now, for this first problem, I'll write it out. What I'm doing is 490 times 249. And you can use a multiplication symbol, or I use parentheses, so I'm actually going to change this, because notice it looked like I had another X all of a sudden. All right, so then now simplify what you know. So this is still 295X. Well, multiplying those 2 numbers together gives you a really nice big number. It's 122,010. All right, and then now we just have to solve for X. Whatever is next to X, whatever number, you will be dividing by that number every time. So that means I'm going to divide both sides by this 295. And I kind of like to write it in the middle. So that's why that 295 cancels. So now we just have to divide our big number by 295. We put those in our calculators. And I get about 413.6. And for my unit, since my pressure was kPa, that's what my answer's unit's going to be, kPa, which is kilopascals. And that's my answer. Ta-da! All right, let's go to 4 more problems. I'm not going to explain those ones as much. I'm just going to kind of like go through, here's the units, blah, blah, blah. Okay? All right, second problem, same thing. We are going to read what's in the problem. And I'm just going to put them into my table. So a container has a volume of 8.55 liters. So I'll put that with the V. And a pressure of 92.6 kilopascals. And what will be the new volume if the pressure is increased? Well, if just by looking at what I knew, if the pressure increases, the volume should decrease. So my answer should be smaller. Well, let's prove it. Prove it with math. So my volume is X. All right, so this time there is no temperatures in this question. So I cross it off in my table, cross it off in my problem. And now I'm just going to enter my variables. So P1, 92.6 times V1, 8.55 is equal to P2, 101.3. And we do not know V2, so I'll leave that as X. So already, I'm just going to simplify this out. Multiply those two numbers, and I get 791.73 equals to 101.3x. Divide both sides by 101.3, and I get x equals about 7.8. And since x was a volume, and this volume was liters, then my answer is liters. Ta-da! All right, in this question, it's not in word format. It just gives us all these things, and we got to find out x. So it gives us all the variables, P1, V1, T1, P2, V2, T2. So this has a lot more numbers. And at first it looks scary, but really it's not that bad. So the first thing we have to do, I just plugged it all in my table, and then I still have to solve for Kelvin. So I have to add 273 to both my values. So my T1 is going to be 294 Kelvin, and my T2 will be 308. So the reason why it has to be in Kelvin is because we cannot divide by 0, and Celsius can be in 0. And also, Celsius or Fahrenheit can be in negative. Well, if you have a negative number and you're multiplying and dividing, then you would get like a negative volume. And you can't have a negative volume. Even a black hole has mass and volume. So that's impossible to have a negative volume in this sense. Okay, so same thing, but now we have all our variables. So I'm not crossing anything out in my equation. I'm just plugging them all in. So let me just use one color for this. I will have 89.5 times 4.5. Actually, I'm going to move this. Sorry about that. Just so I have more space. 89.5 times 4.5 over 294 is equal to 104 times x over 308. All right, so it looks like a lot of numbers, but it's still just cross multiplication. I'm going to multiply all of these numbers together and get one answer. So 89.5 times 4.50 times 308, and you get this nice big number. Ready? 1, 2, 4, 0, 4, 7, so 124,000-ish is equal to, then we multiply the other side. So 294 times 104 times x, and I get 30,576, and x was there, so that's where the x is. Okay, so since x is with that 30,000, I'm going to divide both sides by that number, 30,576. Okay, and when I put that into my calculator, I see x equals about 4.05. And since V was liters for V1, V2 is also liters. Ta-da! Looked complicated, but not too bad, hopefully. Okay? All right. I got 2 more practice problems for you. All right, this question. A gas is held in a rigid glass container at 25 degrees Celsius. So already I'm going to call that my T1 with a pressure of 101.3 kPa. So 101.3 kPa. Because it says that same gas at that time is that. So that's why I know they're both ones. To what temperature must the gas be heated in order for the pressure to rise to 125 kPa? So it even gives us a hint here that the temperature needs to be heated. It needs to be bigger. And just because the other one is in Celsius, everything still needs to be in Kelvin. So I still have to convert it into Kelvin. And my answer is going to now be in Kelvin. So I don't have to worry about it. So I have to add 25 plus 273. And I get 298 when I do that. And then this is my X this time. Or really it's this part, the Kelvin. Okay. The volume is held constant, or because it's a rigid glass container, meaning it's glass, it can't expand or it would break. So that's why there's no volumes in this question. So no volume. The volume has to be held constant because the glass cannot expand. It would break. So if there's way too much, then yeah, it would break. So now we're just going to plug them in without V's in there. And I get, so 101.3 over T1, which is 298, is equal to 225 over X. All right, same thing. We're going to do a cross multiplication. So I would have 101.3x on one side, and then that's equal to 298 times 125, and that's 37,250. I have to solve for x, so since 101.3 is next to my x, that's what I'm dividing by. 101.3x. Well, not the x. Hello. That's really on both sides. If I want to show it this time, I'm doing it on both sides. It cancels it. So that means x equals to 368. And again, since this one we converted to Kelvin, our answer is already in Kelvin. I do not have to add 273 to it or subtract it. Since my temperature 1 I converted to Kelvin, automatically my temperature 2 is also in Kelvin. Isn't that nice? Yay! All right, last question. A gas has a volume of 175 liters in a lavatory in which the temperature is 22 degrees Celsius, assuming pressure is constant. What would the volume of the gas be if the temperature were reduced? So if temperature is decreasing, we found out that the volume will decrease. Well, think of you. When it gets cold outside, you shiver up and you start holding yourself and be like, I'm so cold, I'm shivering. So same thing with gas. It's like you. It gets all small when it gets cold outside. So right now I'm just filling in my table based on what I see and solving for Kelvin. And then this one, I do not know my volume. So that's why it's my X. And 0 degrees. So notice that's why we have to use this. We cannot divide by 0 when we enter this into our equation. So notice there's no pressures. So cross it off in my table, cross it off in my equation. And then I know exactly where all my numbers go. So let's use, I like this blue color, so I'll use this. V1 is 175 over T1, 295, is equal to x, because we do not know where it is, and 273. And again, cross multiplication. So x with 295x is equal to, multiply those two together, and we get 47,775. 295 is next to x, so that means we're going to divide both sides by that number. I kind of write it in the middle, so I know it goes to both sides, but that's what's going to happen. So x will equal to 161.9 liters. Ah, see, it did decrease. Ta-da! So those are my 5 example questions, and just because you made it through the entire video, here's one of my favorite jokes, just because it's going to be another rainy week. Why did Snoop Dogg need an umbrella? Bo drizzle. Bah, 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 bah. I know, I'm hilarious, and you miss me, and I hope you eye rolled just for me. And if you did eye roll, just like film yourself eye rolling and then give it to me, and then I'll be like, yay, eye rolls. That's exactly what I love. You know? All right. I hope this helped you out a lot for that quiz. Like, seriously, watch this before you take the quiz or while you're taking the quiz or something like that. Okay. All right. Okay. Miss ya. Bye.